All right, chemists. So today in class, or earlier in class, we started studying the properties of gases. So we need to have some definitions that go along with these properties. So the first is gas pressure, and this is just the force exerted by a gas onto the walls of its container. Now, remember that gases expand to fill whatever they're being held in. So we measure this gas pressure as the first force exerted by that gas on the walls or whatever it's being contained in. We feel gas pressure on us. Generally, it's around 1 atmosphere of pressure. There are multiple different ways to measure pressure that we will talk about a little bit. But generally, atmosphere is what we use in this class. So, and another way to think about it is that gas pressure is caused by the collisions of gas particles with the walls of the container. So basically, gas pressure is collisions of the gas with its container. So just, I don't know if you can hear this, but I'm like drumming on the table. So I'm putting pressure on the table with these collisions. So you think about the individual gas particles hitting the wall millions of billions of trillions of times per second, and that is the where the gas pressure comes from. Temperature, really the way I want you to think about temperature is as it's a measure of the kinetic energy, really the average kinetic energy of a sample. So if you raise the temperature, what you're really doing is you're raising the kinetic energy. You're making the particles move more quickly. If you cool it down, you're decreasing the temperature, which I'll get to on this next slide. So as temperature increases, the particles move more quickly. This leads to more collisions, more and stronger collisions with the walls of the container. So if I have more strong collisions with the walls of the container, that must mean pressure increases. So a way to say this in a sentence with mathematical relationships is the relationship between pressure and temperature of a gas is direct. It's a direct relationship. Okay, and that's it for this lecture.